Bismillahir Rahmanir Rahim. Hello, guys. This is our third episode in chemistry. We are still in chapter 1, the states of solids, the states of matter. And this is our curriculum for both core and supplement. We already talked about them, and they are here just to remind you whenever you come in that there is a specific curriculum, and we follow the curriculum of 2023 through 2025. Four subtopics for the, or 4 topics for the core, and 2 more topics for the supplement or the extended state distinguishing properties of solids, liquids, and gas. Describe the structure of solids, liquids, and gases in terms of particles, separation, arrangement, and motion. Describe change of state in terms of melting, boiling, evaporating, freezing, and condensing. Describe the effect of temperature and pressure on the volume of a gas. This is our first part for the core. In addition to it, there are two more topics for the supplement or extended. Explain change of state in terms of kinetic particle theory, including the interpretation of heating and cooling curves, and explain in terms of kinetic particle theory that affects the effect of temperature and pressure on the volume of a gas. So this is what we are going to do. Today we will proceed forward and see what's going on. Let us go. For today's episode, we would like to concentrate in 2 topics that they are related to each other. It's about 2 curves, the heating and cooling curves. In other words, we would like to see the effect of heating and cooling on a substance. So what is the heating curve? What is the heating curve? A heating curve of a substance is the relationship of temperature, state of matter when heated over time. Substances undergo phase transition at their melting and boiling points. So this is the important, and this is how it looks like. We are going just in few seconds, a couple of seconds, we are going to explain what are all these, but it looks like this. If we have a substance here, and this substance is solid, and we increase the temperature over time, we are going to and plot every specific interval of time. Try to plot what is happening. We are going to see something like this, and this type of curves that has 3 sides and 2 main plateaus, and we would like to explain just a few minutes how this happens. So be careful about that, because it is very important, and you can never escape question about the effect of heating, or the heating curve, the cooling curve, whatever it is. So just pay attention of what we are trying to do. Let us go. Now, if we have the curve that we just look for, how we can read this curve? how we can interpret this curve, how it works. And as you see here, when you plot and you try to observe things, you are gonna find those points, and also this shape of the graph like a ladder with 3 sides and 2 plateaus. So how we can understand this, and how we can also make some interpretations about this. So first, let us assume that we have a solid substance, and this solid substance, we start to heat it, and we are going to rise the temperature over the time. And every now and then we are going to plot to observe what is happening to this solid, and at the same time to plot any change happens and at what time. We are going to find those points. So what are those points and how we read this? So this solid is going to be heated till it reach its melting point or melting temperature point at B. Then it starts to melt. And then whenever you increase the temperature, nothing happens here, because at this plateau, it's going to stop. The solid is going to stop melting, and here you are going to see some solid plus liquid, because some of the solid have been liquefied. Now, let us assume this solid is an ice. So the ice, when you raise the temperature, is going to, or increase the temperature, is going to melt. When it's going to melt? At 0 degrees centigrade. So it's going to melt here. But melting takes place till reach point C. So in this plateau, I'm going to see some ice plus water. So I have a liquid plus solid in this plateau. So A is the starting temperature. B indicates that the melting point or the melting temperature where the solid substance starts to melt. At the plateau, which is B and C, from B to C is going to be the some solids here, ice for example, and some liquid, water. There is no pure solid nor neither pure solid nor pure water. At C, all the solids at temperature C, all the solids are melted. Then I'm going to have between C and D an only liquid. Between A and B, we have only solid state, solid phase. Then here there is a transition phase where is there some solid plus liquid. But from C to D, we are going to have only liquid. That means we change the solid into completely into liquid. Then at D, the point D is the boiling point. So this liquid starts to boils, and this liquid, if it is water, that means this is going to be 100. D here is going to be 100. Then it starts to boil for some time, where we are going to have another plateau where liquid plus gas is present, and the gas in the form, if it is water, is going to be a water vapor. So there is a starting of vaporization. And then when it comes to E, the liquid is completely transferred into gas, and then we start to heat the gas till the end. So now we have we start with the solid content and then we end with the gas. So we have solid, liquid, and gas, the three states of matter. And at the same time, we have two transitional period or transitional phases between B and C and D and E. And they are going to ask you about what I'm talking about. And here you are going to see each step. So this is the starting temperature plus solid state. This is the starting temperature and we have a solid state. Example, ice. Here AB, which is AB, indicates this line indicates the solid starts to melt, and at B is the melting point, and then solid liquid, we have some solid here, liquid in the transitional phase, and then we have a liquid only, there is no solid, then it starts to boil, and then we have liquid and gas in the second plateau, and then we have a full gas, and gas when you try to heat it, it's not gonna turn to anything else, but it's going to expand. This is what is happening and how we are going to read it the same way. Let us go forward. Okay, we know now what is the heating curve and how we can interpret or read this curve. Now, how we can do this if the case is about the cooling curve. What is the cooling curve? A cooling curve is the line graph that represents the change of phase of matter or the state of matter, typically from gas to a solid or a liquid to a solid when we cool the substance or the gas. That means when we decrease the temperature, we are not going to rise or increase the temperature, we are going to decrease the temperature, and this will let us see this type of graph. We are going forward to try to read and interpret the cooling curve. Now we have the cooling curve. The first thing you have to know is that when you say cooling phase or cooling curve, that means you are decreasing the temperature. We are cooling the substance. We do not increase or heat the substance. We reduce the temperature to the cooling and see what is happening. Now, instead of having solid, we have now gas to start with. So we start with the gas here at this point, and then we are going to decrease the temperature and see what is going to happen. So now we are going first, because this is a high temperature, we start with the high temperature, so we are going to have a steam, a vapor if it is water. So this line, it is not solid now, this line is the steaming and cooling. And now when we go downwards, when we cool it by time, this gas or this steam is going to condense. So here is the condensing temperature of the gas, and here is the steam. Now is we have here gas in addition to some liquid. Then after that, at this point, the gas start to liquefy and becomes water. So we cool it now. So the gas state changed into liquid state. Then here is going to be the freezing point. It's a freezing point of water. Then we have another Plato where we have water, and then the water start to crystalline and solidify to make ice. And then here we have the freezing point where completely all the water changed into the into solid, which is ice completely. And then at the end we reach to the maximum, we have a solid ice. So the difference between the two is that one of them is the mirror image to the other. We are going to see this in the next slide. Okay, but here I would like you to remember the rule of 3 B's. So we have Plato, then we have phase of change where it changed into a different thing, and then potential energy, and we are going to study the potential energy when we come to the kinetic energy and see how we can interpret the cooling curve and the heating curve based on the kinetic particle theory. Here we have two curves, the heating curve and the cooling curve. The heating curve here is the amount of heat added over time, and this is the amount of heat removed over time. By removed, we means we cool the substance. We cool the substance. Here we start with, a solid, while here we start with a gas. This is very important, you have to know. Here we are going to increase the heat, here we are going to decrease the heat. Now let us go one by one. We have two temperature that you have to denote it. Temperature B and temperature F. So temperature F is the freezing temperature or melting temperature. Both are the same. And temperature B is the boiling temperature or the condensation temperature. Okay, both of them are right. Okay, and here we have the Plato for the Platos. We have two Platos, so don't forget the T. And how the phase change from phase to phase or state to state, the transitional state. The Plato is called the transitional state. So this is important. They look like each other. The cooling temperature start from up downwards, while the heating curve start from downwards upwards. Be careful about those together and try to figure out how they look like and how they are actually similar to an object and image in mirror. Okay, this is a good example for this. By this, we finished our third episode on heating and cooling curves. We are gonna stop here, and next time we are going to talk about, we will talk about the kinetic particle theory and see what does it mean and how we can interpret anything related to based on the kinetic energy. or the kinetic particle theory. Thank you and have a good day.